Alright, so this is the abridged version of my project video. For a longer version where I spend more time going over basically the data pre-processing and just go into things a bit more depth, the video is also on this YouTube channel. But here I'm going to review really quickly the data that I collected, where it came from, and what I did to it. Introduce that data with a couple descriptive statistics in R, and then go over 2 of the 4 predictive analytics methods I used to look at the data. And what are those data? They are bills that passed the U.S. House in the 112th to 115th Congresses. And what I'm trying to do is predict what ultimately happens to those bills. Do all of them pass the House? But do once they've done that, do they make it all the way through Congress and become a bill? Do they die in committee? Do they get vetoed? And so on. So I collected data from 3 sources: ProPublica API with information about the bills, the bill text itself from govtrack.us, and scores for this bill sponsor's ideology in 2 dimensions from authors. The data is available online. So I've made all of my project materials available publicly on GitHub at this link right here. The first thing that I'll go to is the Python script that I used to collect and pre-process all of the data. So I collected, like I said, the data from the ProPublica API, GovTrack, the DW nominate data, which you can download as a CSV. Again, the ProPublica API, and then I did pre-processing, which included making some new attributes of my own, including text processing. And the only one I'll point out here is I calculated the number of times each bill directly references existing US code in the text of the bill, and I did that using regular expressions. So basically just searching for any time a substring of each of these patterns occurs in the bill text. And then I put that all together and finally tacked on the end my target variable, which is the fate of the bill. Did it become law? Did it do everything it needed to, but it's not the type of thing that becomes law, like a continuing resolution, which is just an agreement of Congress that doesn't actually change anything in the US code? Did it go to the Senate and then go no further? Did it not even really get out of the House, die in committee? Did it get vetoed, or a bunch of other random things, like did it get tied up in Supreme Court litigation? So I collected and transformed all of the data here in Python, and then piped it into R, where I processed it in an R Markdown file, and I've published the HTML version of that as well, and so you can read that report at that URL. So I'm not going to touch on everything that's in this report, but I will point out some of the highlights. So I have a table of all of the pre-processed data. Here we can see one of the interesting attributes is the primary bill subject, using 32 categories that are defined by the Congressional Research Service. So we can see that bills dealing with certain areas are way more common in these specific Congresses than others. Bills dealing with armed forces, for example, are way more common than bills dealing with social sciences and history, just for one example. Additionally, we can see that the bills that I've collected were more sponsored by Republicans than by Democrats, and we can see that 2 ways. Directly, we can see it here. We can see that there were almost 3 or 4 times as many Republican-sponsored bills than Democratically sponsored bills. We can also see that here broken down by ideology. This ideological score is basically one component from a PCA of roll call votes, and this represents economic ideology. A lower score meaning favoring more government intervention in the economy, and a higher score favoring less. So we can see that more of the bill sponsors are on this right-hand side, which is the economic ideology that is traditionally associated with Republicans. The second dimension is not economic, but social ideology, and we can see that sponsors are actually fairly normally distributed on that account. And we can also see that the sponsors are mostly older folks. This is not a bimodal distribution like the overall US population, which would have a second mode here at about 30. But that makes sense. In general, Congress is just older than the entire US population. So that lines up. Moving straight on, one of the last attributes that I want to point out here are these build text attributes for my text processing. Most of these are highly collinear with each other, and you can see that here in this correlation matrix. Each of these, just raw counts, is going to increase as the overall bill length increases. So in analysis, I ended up only really using one or two of these, usually the USC refs, because it's the most unique and specific to congressional bills. And then finally, my target variable, which I coded in that Python script, has 6 potential values, 6 levels, and some of them are more common. There are only 4 bills vetoed in these 4 Congresses, and so I do lump those in with all of the other bills that passed both chambers of Congress in a dichotomous version of my target variable, which I used in some of my analytics. But in this more broken out variable, I did want to leave vetoed separate because they are qualitatively very different from all the other bills in analysis. So the 4 types of analytics that I attempted to use on this data are broken down: 1 unsupervised learning and 3 supervised learning. So this first one here is k-means clustering, and it's one of the ones that I'm going to go into in some depth here. I dropped a couple columns and did a little additional recoding in order to prep the data for this. And I actually performed this analysis in KNIME, and that I've made that workflow available in the GitHub if you would like to look into it. And after running the cluster analysis, I found that bill length was a strong predictor of a lot of these categories, a lot of the clusters, which is interesting, but not very interesting towards my goal of trying to predict result. So I dropped all of those build text attributes and ran a new cluster analysis. And in each of these, I've been asking for 6 clusters, the same number of levels in my target variable, because ultimately I want to see if these clusters that result are at all informative towards that target variable. Do they line up? Here we can see that half of the clusters are very clearly delineated by the number of co-sponsors for the bill, but these other 3 clusters are very intermingled on all of these axes. So then I went back up here to see what additional attributes might be separating these clusters that aren't plotted here. And this next plot shows that those attributes are sponsor age and sponsor seniority. So this cluster is made up of bills sponsored by younger members, and this cluster and this cluster are made up of bills sponsored by older members, and they are separated by the seniority of that member. So this cluster is bills sponsored by older members who have not been in Congress that long, and this cluster is bills sponsored by older members who have also been serving for a long time. So now that I had figured out what was separating all those clusters, I wanted to know, like I said, is this at all informative towards my end goal and my target variable? And the answer is no. Here I've plotted the proportion of my target variable in each of these 6 clusters, and we can see that no one of these clusters is strongly dominated by any of the results, so they do not line up. So next I moved on to supervised learning, which is definitely better suited for trying to predict a target variable, which is what my goal is. And I did 3 supervised learning models: random forest, decision tree, naive Bayesian, and logistic regression. The random forest tree was pretty good, and I go into that in more length here in the report, which you can read through, but I'm not going to talk about it just for time's sake. And I'm definitely not going to talk about the naive Bayesian modeling because it was truly awful. It had less than 50% accuracy in this run. In a previous run, it had 50.8. So it's a pretty terrible model for my data. So the last type of supervised learning that I try to use on this data is logit regression, which I performed in R with GLM using a binomial distribution and a logit link. So it is a logit model. And in this table, I've pulled out the odds ratios for every predictor in the regression that was statistically significant to the p less than 0.05 level. So we can see that there are 4 variables that are really strong predictors of the bill fate, and that is which Congress the bill was in, what subject it was in, the bill's sponsor's age, and their party. So we can see that from this odds ratio, each successive Congress, the odds that a bill made it all the way through Congress decreased. And we can also see that as the sponsor's age increased, the odds that a bill made it all the way through Congress increased by about 2.8 percentage points. So although that's statistically significant, it practically does not mean very much. And we can also see that the odds that a bill made it all the way through Congress are strongly affected by the sponsor's party. And lastly, which subject area the bill came from also strongly impacted its odds of making it all the way through Congress. These are all relative to bills in the quote-unquote Congress subject. That was the reference category. And so bills in each of these categories were however many more, the odds of a bill in these categories passing were however many more times greater than the odds of a bill in the Congress category passing. And the model performed fairly well. It produced predictions that had similar patterns to reality, although usually off by a standard amount, and that's just because I'm not taking into account all of these. These are predictive marginal effects, basically, and so there are things going on here that are leading to these differences. But overall, the logit regression was fairly good for predicting the outcome. So in conclusion, the clustering was interesting, but supervised learning is definitely the right tool for my task, which was trying to predict an observed outcome. Going forward, I think one thing that would be really interesting is downloading all of the bills that have entered the 116th, the current Congress so far, and trying to use those as a validation set, although we might have to wait until the 116th Congress has ended for it to really be a valid comparison, because those bills are still in play right now. There's also a problem, though. All of these Congresses that I looked at were, the houses were controlled by Republicans, but the House majority in the 116th Congress is held by Democrats. So generalization of any of these findings to a democratically controlled Congress or House would be problematic. There's also more information I could have pulled if I had the time. One idea I had was trying to get some sort of public support attribute for each bill based on public polling, opinion polling data from around the time on a relevant subject, but I didn't have time to do that. And I could also expand analysis to look at bills just introduced into the House instead of those that past the house, that would definitely be a much larger number. But it would introduce some problems with collecting all of this data, and I would have a lot more missing values. But something to think about. So that is that. And like I said, all of these materials are available on GitHub if you want to look at it or read about the models that I had to skip. Thanks.